I'm Ahmed Daud, and in this session, we are going to see a second approach that we have discussed in the last session. Second approach, I was saying that it's a different approach in which we, instead of multiple binary classifiers, we will have one multi-class classifier, which has a little bit different structure compared to the logistic regression. Okay, you can say it's a different algorithm, which is similar to logistic regression, with some changes that makes it capable of handling multiple classes. Okay, so in the case of logistic regression, we were doing the uh, in that way. If I will say that how logistic regression usually works, logistic regression. I have explained this multiple times. I hope you will be quite familiar with this. Okay, so first we are having some score mx plus c, and we apply some logistic function on that score for the sake of getting probability belonging to class 1. Let's say the probability belonging to class 1 is 0.4. So this will be belonging to 1. As we know, we have squeezed our value in the range of 0 to 1 by applying logistic function. So if 0.4 will be the probability belonging to class 1, then opposite side of that, which will be a 0.6, this will be a probability of belonging to class 0. Okay, and whatever threshold we usually set in binary case, we will get the prediction accordingly. But and you also know the cost function that we already have discussed in the case of logistic regression. We are having cost function like this for the single instance. If the given sample is belonging to class 1, then the cost function will be this. If belonging to 0, then the cost function will be this. And if we want to have a cost function for the whole data set in which all the m number of samples, and it will add all the cost like from I is equal to 1 to up to m, it add all the costs. Okay, all the, you can say, differences between the probabilities and the actual values. So in that way, it has like this structure. Okay, if the sample belonging to one category, this will be uh, this block. If I will use different color here, this will be used, and other term will become 0 here. Okay, 1 minus 1 will be 0, and it make this term all equal to 0. And in the opposite way, if the sample is belonging to 0 category, then here will be y is equal to 0, and this term will be 0, and this will be scattered here. Okay, so in this way, cost against each sample is calculated, and sum up all the cost for the sake of training the algorithm, and train the algorithm that way that the cost of cost function, which is j, is minimized. Okay, we actually finding out the parameter values, best fit parameters, and these are the parameters, and this is mx plus c, which you can extend. It's up to you. Uh, like if mi xi, there are let's say there are three features. Sorry, we have a data set here, four features. So if you have four features, so it will be like this: m0, x0, m1, x1 up to m4, x4, and m0 is intercept. Okay, so in the case of softmax regression, which is actually for the case of multi-class classification, so how it works? Instead of just one score, in the case of we were having logistic regression, in softmax regression, we will have as much number of scores as much we classes have. Let's say we have a data set like we were having in the last session, in which there are four independent variables and one target column, and in that there are three classes: Stosa, Versicolor, and Virginica. We have three classes here, and against three classes, softmax model will have three equations for the sake of getting three scores against each class. Let's say this equation will give the score against this Stosa class, this will give against the Versicolor class, and this will give a score against the Virginica class. And here it is actually representing in the form of matrices. and it's up to you. You can represent in any way. So there will be five parameter values in that case, five parameter values here, five parameter values here. So 15 parameter values we are having here. We have three classes, we have three scores equations, and against each score equation there are five parameter values. So there are total 15 parameter values, and it's the exactly same, that is softmax score for the class K. Okay, this screenshot I have taken from hands on machine learning book, which is pretty good. Okay, I will really recommend to have a look on that book also. Okay, so anyway, come back. We have gotten three scores. Now we have to get three probabilities against three classes. Okay, and which class will have high probability will be considered as a output. So in that way, we will in the case of logistic regression, we were using a logistic function, which is 1 over 1 plus e raised to power minus x. But in the case of softmax regression, we will use softmax function, which have structure like this. Okay, like this. If you want to see the probability of class 1, let's say class 1, which is TOSA, we are having our score, which is score 1, let's say um, m0 x0 plus m1 x1 up to m2 x2. And if you want to see the score of want to see the probability of belonging to stosa category, so it will be like this: e raised to power score 1 divided by e raised to power s1 plus e raised to power s2 plus e raised to power s3. Okay, this will be probability of belonging to stosa category. In that way, there will be three probabilities against three scores. Okay, this is the exactly the same. Okay, and here you can see k is number of classes, capital K, and there is in the denominator there is summation. Sx, this is a, it's a vector. This is actually a vector of containing three scores. And when you want to see some score of probability of some particular category, you can have to take a softmax function of having numerator. In the numerator there will be score of the belonging to that category, and in the denominator there will be a sum. Okay, this is the same that I am explaining here. Okay, against three classes you will have three probabilities like this. Okay, uh, and you can see here e raised to power score 1 divided by sum, e raised to power score 2 divided by sum, e raised to power score 3 divided by sum. Now you will have three probabilities, and in this way this model's equation is actually work. You have three classes. Against three classes you will have three scores equations, and each score equation will have five coefficients, five parameter values, four coefficient, one intercept. So there will be three scores, or means 15 parameter values, and against three scores there will be three probabilities, and this will be the equation. Now whenever you will train your softmax regressor, you want to find best 15 parameter values, and then after the training process, when the training is complete, whenever you will pass a sample to that softmax regressor, which probability will be max out of all the probabilities. Let's say this p2 is max in against some particular sample, then the output will be considered as a versicolor. Okay, versicolor. In that way this process is carried out. Now you got an idea of the difference between logistic regression and the softmax regression in terms of model equation. Now we'll see how we can train softmax regressor. It's pretty same. If I will show you here, this is the cost function for the logistic regression, which is actually called log loss or cross entropy function for the binary case. Cross entropy for the binary case. Okay, and in the case of softmax regression, cross entropy function is used, which is generalized cross entropy, no matter how much classes you are using. It is strictly for the binary case. But in the case of softmax, we will use this type of cross entropy function. Okay, no matter how much classes you are using, this type of cost function. Let's say you are, if you are using a multi-class classification problem in which there are three classes, let's say three classes according to our species problem. Okay, you will have cost function like this: g of theta, or number of samples according to number of samples minus 1 over m, and then you have to sum all the costs against each sample, and you will have the like this y1 log p1, y2 log p2, y3 log p3. Okay, so whenever let's say a sample is passed, let's say you are training your algorithm, softmax algorithm on that particular data set, and let's say this sample is passed here, this particular sample is passed to that equation. So there is a this category virginica. So in that case, y1 is equal to 0, y2 is equal to 0, y3 is equal to 1. Okay, because this is virginica, it's not a stosa, not a versicolor. So y3 is equal to 1. So this cost function will become, this whole term will become 0, just because of y1 is 0 here. This will become 0, and this will be scatter here, and here log of p3. Okay, and p3, you know, it's a equation probability which will have sorry, e raised to power s3 divided by e raised to power s1 plus e raised to power s2 plus e raised to power s3. Okay, this type of probabilities equation this have. Okay, so in that way, like you know, others terms become 0. In the case of logistic regression, we have just two classes. When our sample belonging to one class comes, the log p becomes usually scatter, and other term becomes 0. In the same way, if sample belonging to virginica comes, then the probability belonging to virginica will be scatter, other will become 0. Okay, and in the same way, like you have in the case of logistic regression, you have a cost function for the single training instance. You can also write the cost function for the single training instance from this cross entropy. If the class is one, which is let's say if the class is stosa, sample comes belonging to class stosa, then the cost function will be this. If belonging to versicolor, sample comes during the training process belonging to versicolor, then the cost will be this. If sample become belonging to virginica, then the cost will be this. Okay, so this is the cost for the single instance, and when you will sum up all the costs, this will be like this. Understand? Okay, so it's pretty same. This is that's why it is cross entropy function. It's the same cross entropy function that we have used in the case of logistic regression, but that was for the binary case, and it's a generalized cross entropy function. So for the simplicity, you have here uh, multi-class classifier, which is softmax regressor. You have a bigger equation, models equation, and you also have bigger cost function. Okay, in the case of obvious scheme, you are training multiple binary classifiers separately, but here you are like a big shark. You are training one big classifier in one go, that can be able to handle multiple classes. Okay, so this is the for the sake of theoretical uh, explanation. Okay, regarding implementation, it's again pretty simple. If I will show you here, just to give you an idea how it actually works, and if I will show you regarding the coding part, it's pretty easy. Just you have to mention the multi-class is equal to multinomial, and it means that you are using softmax regress. If you are pass the value OVR, it means that you are using multiple binary classifiers, or you can say multiple logistic classifiers. Okay, if there are three classes, then this will be a multiple binary classifier, three multiple binary classifier. And if you will pass a multi-class is equal multinomial, then you are using one softmax regressor. Okay, just you have to pass multinomial value, and you are able to get softmax regression and just train and just enjoy that. Okay, how you can implement here? Pretty easy. Multinomial, logistic regression, pass the value, multi-class is equal to multinomial. Then the train, I will train the same data set, X train, Y train, which has 105 samples, 4 independent variables, and 3 categories. In the same way, when we will train this algorithm, it will detect first how many number of classes. There are 3 classes, so it has to now detect how many independent values here. Independent columns. There are 4 independent columns. Sepal length, sepal width, petal length, petal width. Mm, this you can see. Okay, so it will have 4 independent variables, so 4 coefficient for each score, plus 1 intercept, so 5 parameters for each score. There are 3 classes, so there should be 3 scores, and 5 parameters for each score, so there will be 15 parameter values will be obtained during the training of that logistic regression. So during the training part of this logistic regression, 15 best parameter values are obtained. And you can see from here by multinomial dot coefficients, these are the 4 coefficients for the first equation, score 1, and in the way this is for the score 2, this is the for the score 3. For the if you will compare with the OVR scheme, it's pretty much similar, but in the case of OVR, keep in mind these are the separate binary classifiers, but in the case of Softmax regression, it's a one bigger multi-class classifier. Okay, same way 3 intercepts again for the 3 scores, and you have test data set. You simply pass your test data set, let's say, for the to see the probabilities of your probabilities against each sample. Like you have these samples, and against each sample you will get 3 probabilities. First probability is belonging to Stosa category, second will be belonging to vesicular, and third probability belonging to Virginica. And which category will have a high probability will be the output. Okay, here you will have 3 probabilities against each sample, and which have highest probability will be considered as your like here you can see first sample have iris tosa output. Okay, so it means that this probability is highest. You can see here it's a 0.98. It's pretty low, and it's also quite low. So this probability is quite high, and this probability belonging to this Stosa category. So that's why the output is Stosa here. Pretty much easier, and output is also Stosa. So true value is also Stosa. So for now, I hope you got an idea that how softmax regressor actually work. You have 2 approaches, because you not cannot implement directly binary classifier that we already have studied linear classifier, which is logistic regression. So one approach is one versus rest that we have discussed, and one approach in which there is a little bit change in the model's equation of logistic regression, and we got another algorithm which is softmax regression. For the sake of implementation, it's pretty much easy. Just pass the value OVR scheme you are using, just pass the value multinomial, and then you are using softmax regression. Okay, in that way you can able to train a multi-class classifier and predict multi-class problems. Now the problem that in the coming session we will discuss how we can evaluate our multi-class classifiers, how we can check how good our model is, the performance measures like we have um, uh, understand in the case of binary classifiers. uh, we will discuss here also. So next session will be quite interesting also. And the one major concept, keep in mind that there will be no concept of threshold setting in the multi-class case. So for now,